Alright, today we are finishing up our notes from yesterday. And you might notice I got these cool little flags in my hand. What are they for? Find out today. No, they're not white. Exactly. We'll get to that in a minute. So, y'all remember what cross sections are from yesterday? Okay, who can tell me what a cross section is in their own words? Yes. Okay, they can sometimes parallel to the base, sometimes they're vertical, but it's basically when you do what? You slice, okay? It's like taking a little slice out of anything, okay? So a cross section is like cut. So as you see on the board right here, we did these, okay? We took a little slice out of this pyramid, we got a little square, right? We took a slice out of this cone, we got a circle, right? So make sure you're looking up here, set your phone or anything else, so that way you don't miss out on something, okay? Because this is new stuff, right? So here's the other cross sections we talked about yesterday. As long as you cut parallel to the base, you're going to get the exact same shape as the base, right? However, on a sphere, there is no base, but that's obviously a circle when you cut it, right? So we talked about down here, what happens if you cut it vertically? And if you cut it vertically, you got to look at the shape you see vertically. So right here on number 6, didn't we see a rectangle straight up and down here in red? So guess what? We get a rectangle when we cut it vertically. Parallel to the base, so that if my keyword is base, that means I just look at the base, and my blue base over here is a hexagon, right? So we're just taking slices today. That's what we talked about yesterday, actually. But today, okay, on the back of the notes, we are going to rotate them, okay? So we're going to take that two-dimensional figure, the cross section, and we're going to rotate it, okay? So it says we can rotate the cross section to create a new 3D object when a rectangle is rotated around a line. So does everyone see right here? Right here, we have a rectangle on a line, okay? And it's supposed to be rotated around and around and around. And when you rotate that rectangle round and round and round, it's supposed to make a 3D figure. So when it's being rotated, obviously these edges are being turned around to make circles, right? And what do we call it when we get this shape with circles on top and bottom? What's that called? A cylinder, okay? So if you don't believe that, maybe you'll believe my cool little thing I'm going to show you here. All right. So I've got a rectangle on a paper clip, right? Super cool. And the question is, what happens if I take this and I rotate it super fast, right? Now, I'm not good at rotating this super fast, but if I rotate it as fast as I possibly can, you would eventually just see a blur, and there would be a circle on top and a circle on the bottom, and that would be giving you a cylinder, okay? So when you take a rectangle and rotate it, circles on top and bottom, that gives you a cylinder, okay? So I want you to underline or circle this stuff. This is very important, because if you don't like visual stuff, then here's the notes of it. Rectangles being rotated make a cylinder. Every single time you do one of these problems, and your cross section is a rectangle or a square, and it says the word rotate, the answer is going to be cylinder. Because you rotate that rectangle or square, you're definitely going to get a cylinder, okay? Now, in this little space below it, we're going to investigate what if it's a triangle, okay? So, if you look up here, I made one for a triangle, okay? Now, what if I took this triangle and I rotated it, and I kept rotating it and rotating it really fast? What shape is that making? A cone, right? You see how this down here is making a circle, but the top is still a point? So when you have a circle on the bottom and a point up top, super fast, super fast, super fast, that makes a cone, okay? So underneath this, let's write some notes real quick, okay? If I take a triangle and I rotate it, it's going to give me a cone. That's the notes, okay? So there's the main two things. So, two things. Rectangle makes a cylinder when you rotate it. Triangle makes a cone when you rotate it. So let's take that information to the bottom, okay? It says, identify the three-dimensional object generated by rotating a two-dimensional shape as described, which is just a fancy way of saying we're going to do the rotation thing, right? But it's not the first thing we're going to do. The first thing we're going to do is do what we did yesterday. We're going to do the slice, and then we're going to do the rotate. Two things. So, what does it say? Find the cross section. Remember, that's the slice. Parallel to the base. Can everyone circle that? Because again, these key words tell you what you need to look for. Base tells you it's going to be exactly the same as the base. Now, what does it say the shape is? Base of a right triangular prism. Take a wild guess. What do you think the base is of a right triangular prism? A right triangle. Very good. So, if it says something in front of the word prism or something in front of the word pyramid, that's the base. The base is in the name of the figure. So check it out. When you see the word base, it's about to tell you what the base is. Okay? And we know from the front of these notes that if you're doing a cross section parallel to the base, it's going to be the same exact shape as the base. Okay? Trying to make this simple. Now, if you like visuals, I'll draw a picture for you. What is a right triangular prism? Well, it has a right triangle base and a right triangle base. And then we come and take a slice in the middle of it. And we get a right triangle, just like we thought, okay? So, the answer to the first sentence of number 10 is right triangle. We found the cross section. Yay! Okay, so right triangle, let's write that down. That's the first thing you had to do, is find the cross section. You're going to have to do this today, so I hope everyone's paying attention. Then, what you're going to do is mentally, you're going to take that cross section and you're going to put it on a stick. And, remember the little flag? You're going to do what? The next sentence says, rotate the cross section around a line that runs along one side of the right triangular base. What 3D object is created? Okay, so, check it out. When I rotate the right triangle, what shape do I get? We set it up here. A cone. So anytime you rotate a right triangle, you get a cone. So let me draw that for you. When it's being rotated, the bottom's going to be a circle, the top's still a point, looks like a cone. So does everyone see the two answers here? What's the cross section and what's the rotated cross section? Okay? One is 2D and one is 3D. Okay? Let's try number 11. Same idea. So let's read it carefully. It says, find the cross section. I got to find my slice, right? Parallel to the base. So I'm not doing vertical. I'm doing the base one, right? Base of what? A square pyramid. Now, what is the base of a square pyramid? A square. It's in the name, right? And these are the notes from yesterday, if you got them. It's the back page. So the base of a square pyramid, I'm telling you, it's going to be a square. But just in case you like to see the visual, let's draw a square pyramid. I got my square pyramid, and if I were to cut it parallel to the base up here somewhere, well, I'd get another square. So what's the first answer? What's the cross section? A square. So remember, first step, what's the cross section? And then I'm going to take that cross section, I'm going to put it on a stick. And you remember from my little flag looking thing, when I take a square and I rotate it super fast, make circles on top and bottom, what's that called? A cylinder. We also don't forget what we just circled up here. A rectangle being rotated makes a cylinder. And a square is a rectangle, right? Pretty much. There's only one other shape, which we'll see on number 12. But this rectangle, when it's being rotated around that axis, makes circles on top, circles on bottom. Hey, that's a cylinder. Okay? So again, triangle rotation, cone. Rectangle rotation, cylinder. There's only one other possibility. So look at number 12. Identify the 3D object generated by rotating a semicircle. What's a semicircle? It's a half circle. And we're going to rotate it on its straight edge. Okay? So, here's my line, here's my semicircle. Now, I don't have a little flag for this, but you can imagine, with your imagination, that if you took a half circle and you started rotating it, what do you think it would make? Good. So, it would be round over here, round all the way around. It would be a sphere, right? So, when you rotate a semicircle on its straight edge, or if you were to rotate a circle down the center, you would get a sphere when you rotate it. Okay, so those are the possibilities when you're rotating. Okay, now that's all the notes that you need to do the assignment. Okay, now the assignment I'm going to pass out now is one-sided. It's cross sections and rotations, just like we just talked about yesterday and today. This is a shorter assignment, one-sided, no backside, because I need you to finish the assignment from Monday and Tuesday. All the nets are on that table over there. You can do it. I've had a lot of people wasting time today, which doesn't make sense given some of our averages. Okay, so you want to knock this out. Do any missing work you can. And I'm letting you know tomorrow we're going to try to have some time to make up that test we talked about yesterday, because some of us need to retake it, right? So, let's go and get started. Ask questions as needed.